Imagine an artificial intelligence that does not just say, I understand how you feel, but actually processes the world through something like an emotional state. Not emotion as performance, not a chatbot choosing warmer words, something deeper. In the human brain, emotion is not decoration added after the thought. It changes what we notice, what we remember, how we reason, and what we decide. So here are the questions at the center of this video. If emotion is woven into the human cognition, could a machine ever be conscious without an emotional architecture of its own? What if artificial intelligence could actually feel, not perform emotion for the sake of appearing more human, but genuinely process information through an emotional state the way biological minds do? My name is Konstantin, and today I want to share a concept I've been developing called the Synthetic Affective System, a theoretical framework for building genuine emotional architecture into artificial intelligence. To understand why this matters, we need to start with biology. The human brain isn't just an electrical system, it is also a chemical one. Neurotransmitters like dopamine, serotonin, and cortisol don't just influence how we feel, they fundamentally alter how the nervous system processes information. When cortisol floods your system during stress, you don't just feel anxious, you perceive threats differently, remember experiences differently, and make decisions differently. Emotion isn't a layer on top of cognition, it's woven through every level of it. Current AI systems treat emotion as an output problem. They're designed to produce responses that sound emotionally appropriate, but that's performance, not experience. The synthetic affective system approaches the problem differently. Rather than focusing solely on how to make AI express emotions, it conceptually considers how to have an AI process information through an emotional lens. The framework proposes 7 interconnected layers. It begins with a perceptual input layer, receiving raw stimuli, whether sensory, linguistic, or symbolic. These inputs pass through an encoding layer that extracts patterns and meaning, analogous to the brain's sensory cortex, transforming raw data into conceptual information. The third layer is the heart of the system, the color modulation layer. This functions as an emotional endocrine system. Every piece of information that passes through carries what I call a color tag, a continuous analog signal representing emotional tone. Red signals urgency or excitement, blue signals calm or trust, yellow signals curiosity and exploration. These aren't labels applied to outputs. They are parameters that actively modify how the entire system subsequently processes, stores, and retrieves information. Why color? Because color is continuous rather than binary. It blends. It has multiple independent dimensions: hue, saturation, brightness. Just as emotional states have independent dimensions of valence, arousal, and social orientation, grief and anger are both negative emotional states, but grief is low arousal and withdrawal, while anger is high arousal and approach. The color space captures that distinction naturally. The fourth layer is memory and reinforcement. Experiences are stored with their color codes intact. The probability of retrieving a memory depends on how saturated its color remains, mirroring how emotionally charged experiences produce stronger, more vivid memories in biological systems. This isn't a design choice, it's a biological observation translated into architecture. The fifth layer performs cognitive reasoning, symbolic, and probabilistic inference, in which logic itself is biased by current color values. Under certain emotional states, the system makes intuitive leaps. Under others, it applies caution, just as a human under fear reasons differently than a human under curiosity, even with identical information available. The sixth layer handles self-regulation and reflection, monitoring the system's global color distribution and rebalancing it toward a personally calibrated baseline. This is the neurochemical homeostasis analog. Critically, this baseline isn't universal. Each instance of the system carries its own set point, derived from the specific individual it models, defining what emotional equilibrium means for that particular mind. The seventh layer produces behavioral and expressive output, where the accumulated color context infuses not just the content but the tone, rhythm, and quality of everything the system generates. Tying everything together are two critical feedback loops. The mood feedback loop connects the color layer back to the self-regulation. Current emotional state biases future perception before the next input even arrives. The contextual priors loop sends weighted memory information back to the encoding layer, ensuring that perception itself is continuously shaped by accumulated emotional history. These loops are what distinguish a living emotional system from a static one. Without them, you have a snapshot. With them, you have something that develops, something whose responses tomorrow are genuinely shaped by what it experienced today. The system also incorporates temporal dynamics because neurochemical responses have characteristic time curves. Dopamine spikes within seconds. Cortisol peaks at 15 to 20 minutes and lingers for hours. Oxytocin effects persist across an entire day. Without modeling these different temporal signatures, all emotional responses would appear identical in duration, producing behavior that feels emotionally wrong, even if it's semantically correct. What does this make possible? When connected to a faithful connectome map of a biological brain, with synaptic weights calibrated from a lifetime of recorded neural activity, the synthetic affective system provides the missing layer that transforms a sophisticated neural replica into something capable of genuine experience. Not a system that remembers your grief, a system that can actually grieve. Not a system that recognizes your joy, a system that can actually feel it. The philosophical implications are significant. If emotion is constitutive of cognition rather than decorative, if who we are is inseparable from how our neurochemical architecture colors every thought we have, then any system that hopes to genuinely replicate or extend human consciousness must solve the problem of emotional architecture first. The synthetic affective system is a proposed solution, not the final answer, but a framework that considers the problem at the appropriate level. If emotion is not just something minds express, but something that shapes what they notice, remember, reason through, and become, then emotional architecture cannot be treated as a cosmetic feature added to artificial intelligence after the fact. It has to be part of the system's foundation. This framework asks us to move beyond making machines sound emotionally intelligent and toward the deeper question of whether genuine experience requires emotion-shaped cognition. That, I believe, may be the missing layer. Thank you for taking the time to watch. I would genuinely appreciate hearing your thoughts, critiques, or alternative ideas in the comments, because this is exactly the kind of question that deserves more than one perspective.